Welcome back to the chart table. Today we're going to be pre-calculating stars. Now you want to do this before the morning civil nautical twilight and obviously evening civil nautical twilight. Only need a couple things. You need the date in question, DR latitude and longitude, your time in GMT. So you convert your local time to GMT. And we're going to end up finding the LHA of Aries. With that, we need a nautical almanac. To find your LHA of Aries, you first bring up your nautical almanac, and you go to the day in question. For this day, 09 December 2025. With the hours on the daily pages, you're going to find 22 hours. With that, it gives us a GHA of Aries of 48 degrees, 53.7. Now you go to the increments and corrections page for the minutes, and you're going to find the table that says Aries. You're going to find, since we don't have seconds in here, just to make it a little bit easier for us, you're just going to right to the top where it says 0 seconds and find that, which gives us 4 degrees, 0.7. That was for minutes. This is for hours. All right, once you find your GHA of Aries for hours and minutes, to get total, all you have to do is add them together. So total GHA being 52 degrees, 54.4 minutes. Now, to get your LHA, you got to take your longitude from your DR longitude and bring it down here. But we're going to form it up a little bit differently to get our assumed longitude. And all assumed longitude is taking your degrees for your longitude and then matching your total GHAs minutes and seconds. And that'll be your assumed longitude. That'll come into question a lot more once we go to plot these sun lines, or star lines, excuse me. Since we're in Western Hemisphere, it'll be always subtracting. If it was east, it'll add it. This zeroes out because we want a whole degree of LHA when we go into the publication. And all you're going to do is 52 minus 76. You obviously get a negative number, negative 24. Since GHA starts over, LHA starts over once it hits the prime meridian, it's a full 360, so you're going to add 360 to it to make it positive, making our answer 336 LHA of Aries. All right, with your LHA and your assumed latitude, now we can go ahead and plug in our assumed position. Assumed position is basically taking your longitude from here, .76 degrees, 54.4 west. And for our latitude, I'm going to go ahead and round this to the closest degree, because how close our minutes is to the next whole degree, it's literally less than 4. I'm going to use 37 for it. Makes things a little bit easier, especially when you're going into the publication. Like I said, the assumed position comes into play more when you're going to plot these, especially when we're going to do the strip form to get the star lines. So we'll leave that there. With finding the LHA and having our assumed latitude, we can now go into Pub 249, Volume 1, which is selected stars. Now, when you're looking at this publication, it has a date on it. In this example, you have 2025, meaning this publication's good 4 years before 2025 and 4 years after 2025. And every year after that, there's an added correction that you see in table 5 of this publication. Since this publication came out in 2025 and we're using a 2025 date, there is no correction. So going into pub 249, go to 37 degrees north, and you're going to find an LHA of 336. Now, once you go in there, you'll see stars lined up at the top. Some of them are diamonds. Those diamonds mean not just that they're the brightest stars, but they're the easiest ones to triangulate to try to get that perfect pinwheel in on your universal plotting sheet when you go to plot these. So for this example, I'm just using the diamonds. In real life, if I was on the ship, I'll be writing down every single star that this publication gives us, and then some planets when we do that one, to try to make your answer as accurate as possible. So for this example, I'm just going to put the 3 diamonds that it gives us, and then I would write the rest of them down. But the first diamond it gives us is Capella. You're going to write down its HC, which is 17 degrees 36. And you're going to write its bearing that it gives us too, the ZN, 045. And that's always true. The next diamond it gives us is Fomalhaut. With a HC of 23 degrees, 00 minutes. Pretty easy. With a bearing of 172 degrees true. And the final star, Vega, probably one of the most well-known stars out there besides Polaris, 46 degrees, 04 minutes, with a bearing of 290 degrees true. Now, this little table is not readily available. I made this myself. I like to be organized. Now, either I'll print it out like this, or I'll just get a piece of computer paper and make a little table. That way I have the stars I want, its computed altitude based off the publication, its bearing. And when I go out during nautical twilight, I'll find HS, which is the sextant angle, whatever the sextant says, and I'll do a time check whenever I got that altitude. With this information, when you go out during nautical twilight, you're going to set the sextant to this. You put 17 degrees on the arc and turn the micrometer drum until it hits 36 minutes. Then you'll go out in your bridge wing and look at the 045 degrees true direction and scan the horizon. Hopefully you see a little white dot. Now, some of these stars are dimmer than the others. Sometimes you have cloud cover. Then you have to go off the rest of the stars right there. That's why I said you would write down all the other stars just in case you can't get the 3 main ones you want. Because you always want to try to get a minimum of 3 based off NavDorm requirements. So with that, hope you enjoyed this video. There's other ways we can find our stars. That'll be another video, especially with the Root Star Finder. If you haven't heard of one of those or have one of those, we'll show you what it is. The next video will be plotting these stars on a universal plotting sheet. Thanks for joining.